Hey, College Algebra, coming at you for our sixth and final video example for section 5-6. Here we go. We are looking at supply and demand for this, a little economics, kind of changing gears. And of course, this applies to so many different things, this exponential type information. Let's take a look at this. So very similar to your textbook problem, we have supply and demand functions. I said, well, you got Christmas coming up. Anna's been asking for a Barbie dream house or something like that. So let's suppose it's a Christmas toy like that. I don't know. We're going to say the supply is given by this function here, 1200 times e to the 0.006p. And the demand function is 3600 times e to the negative 0.005p. So we have the supply with an exponential growth and the demand exponential decay, and that's based on p, the selling price. Price is p, so it kind of makes sense that the higher the price, the lower the demand, because if it gets too expensive, people aren't going to buy it, right? And then if you put the price high, your supply is probably going to go up because you're going to have a bunch left over. Nobody wants to buy. So there's a balance there, right? Supply and demand are going back and forth. So we are trying to find what we call the equilibrium price, where the demand function equals the supply function, that perfect balancing point where the supply and demand are equal. Right? That's good information for a company to know. What do you set the price at, right? So here we go. That means we're going to take the demand function, this guy right here, which is 3600 e to the negative 0.005p, and put that equal to the supply function, which is 1200 times e to the 0.006p. Okay, now this is a little different equation than we've been seeing. We have some exponential functions that we've been used to, but what's going on when you got an e on both sides, right? Variable on both sides. Well, as you might expect, the wise thing to do would be to eventually use a natural log to cancel the e out. There is a bit of a dilemma with the 1200. So you might say, oh, well, let's divide, right? Let's divide that over. I would agree. Okay, I would not disagree with that. But we're going to see it's not quite that simple. But let's go ahead and start that way. Why not? Let's suppose we say, okay, let's divide, because we're usually thinking, well, we need to get the e by itself. So let's do it. Let's do it. Okay, that's going to cancel out on the right side. 3600 divided by 1200. That's pretty nice. That's just 3. That's 3. So we got 3 e to the negative 0.005p equals e to the 0.006p right there. Okay. So now, okay, let's use the old natural log. Let's go for it. Okay, here we go. Natural log of both sides. Right there, right there. This one cancels out the e. Okay, you might say, well, doesn't it cancel out the e on the left side? Well, not yet. It will, but not yet. There's a 3. It's a 3 times that in there. That's a little bit of a dilemma. And actually, if you had the guts to work out number 59 on the last assignment with some algebra, you would have run into the same problem. And perhaps you would know then how to deal with this. That 3, you can't just make it disappear. The natural log does not cancel it out. You can't just take it out of the log. That's not right. But what you can do is, as I said, consider it a product of 3 times, we got 3 times e to the negative 0.005p. And when you have a product in any kind of logarithm, you can split up the logarithm into 2 separate logarithms as a sum. Product to sum property. You can do that. So I can say this is the natural log of just 3 plus, there's the sum, plus the natural log of just the e to the negative 0.005p. Okay. Now I didn't have to worry about that on the right side because of that side I got rid of the 1200, so I only had the e. So my right side's looking good. It's just 0.006p. Okay, we don't have to worry about too much on the right side. But this left side is where we need some work. Okay, now now that I have that natural log split up into 2 separate ones, the one with just the e, I meant to change colors there, but it's no big deal, I guess. That one cancels out now. Okay, but you do still have this guy. All right, so where we're at now is that we got the natural log of 3, which is some irrational decimal number. I'm not going to worry about that quite yet. Plus a negative, actually I could just say that's a minus 0.005p equals 0.006p. Okay, and we're still thinking in terms of kind of some algebra here, so I'm still thinking, I'm trying to solve for p, right? I'm almost there because I have this minus 0.005p. I can just add that to the other side. Okay, and cancel that out on the left side, and then add those together. So I have 0.011, 6 and 5 is 11, carry the 1, like that, equals, and on the left side I got the natural log of 3, whatever that is, some decimal number. And then I'm finally ready to solve for p because I can just divide the 0.011, 0.011, and let's see, what does the calculator say that is? The natural log of 3 divided by 0.011. Okay, here we go. I got an answer. It says 99.87 is approximately p. Hopefully you know why I'm rounded to 2 decimal places, not 4, not 3, not 1, because this is a price. Dollars, just under $100. It looks like would be the equilibrium price. And oh boy, does that mean I have to pay that much money for Anna's Christmas present? Whew, we'll see. Okay. Oh man, maybe Grandpa can chip in. But anyway, okay. Oh, I got a cake in the oven. It's done. Hear the beeps probably. All right, there we go. That is the last example I have. That's the bottom of the page, bottom of the file. Boom, there it is. Okay. Hopefully that guides you through the last problem. As always, let me know if you have any questions. And take care, and I'll look forward to seeing you the next day in school. Bye-bye.